Hey guys, it's Mr. Cozy, and this is video 35. We are looking at quadratic inequalities. So let's get started. When we solved linear inequalities, when we solve something like this, this is a linear inequality. Our largest exponent is 1, and essentially what we do is we pretend like this is an equation, and we just keep that inequality going, and when we're done we have an answer. The reason why this works, we really aren't solving the inequality here per se. What we are doing is trying to find out where this expression equals 0. That's what we are concerned about, because if you look at the graph of this expression, okay, remember that y values are the value of this expression for certain x's. What the graph shows us is it shows us where the expression is negative or below the x-axis, or positive or above the x-axis. And the transition point where it changes from negative to positive is right here, where the expression is 0. So what we are actually doing when we solve something like this is we are finding where the expression equals 0, because that's where it transitions from positive above the x-axis to negative below the x-axis, or vice versa. And it just so happens that we get lucky, and if we maintain this inequality through the problem, that's actually the range of x values that give us negative results in this case, because it's less than 0. Negative results for this expression. Okay? So solving a linear inequality is not really about getting x alone so much as it is about trying to find out where this thing equals 0, because that's where it transitions from being above the x-axis to below, or vice versa. So this is where we want to look as far as where the expression is positive or negative. And I bring that up because when we look at a quadratic, it's a slightly different story. Now, our first impulse that we inherit from this kind of a problem is still a good one. Pretend that this is an equation and solve it. The problem is that in a quadratic inequality, that impulse will do a lot less for us, and I'll show you why in a moment. So let's pretend that this is an equation and solve it. X squared plus 2x. I pull everything to one side. Minus 8 is less than 0. I factor x plus 4, x minus 2 is less than 0. Okay, and I can even take a look at each of my two factors and say, okay, here x is negative 4 and here x is 2. Okay, all of this is good stuff. The problem is that we really haven't solved the inequality yet. And what we have really doesn't tell us a lot. And here's the problem. If something is quadratic, so let's take a look at the graph of this. Okay, so x squared plus 2x minus 8. The graph of this is not a line. It's a U shape, meaning that there is some region where we are above the x-axis, we hit 0, and then we go under the x-axis. So we go from above the x-axis, positive, to below the x-axis, negative. But we don't stay there because it's a U shape. We come back up, cross the x-axis again, and become positive again. So solving a quadratic inequality is a more complicated kind of a question because of the shape of the line. It isn't good enough just to find where this thing equals 0. We have to do a little more in investigation. What we have to do is what's called a sign table. Now, the first step in creating a sign table is essentially what I have done here, is to pretend that this is an equation, pull everything to one side, and factor, and find out where that expression is 0. And so we have done all of that through here, but there's more to do. For your next step, make a number line and mark where the expression equals 0. Okay? These zeros divide my number line into 3 regions. Here, here, and here. What's going to happen is I'm going to choose an x value from each region of the number line. Okay, so I'm going to choose an x that's less than -4, let's say -6. Choose an x that is 0, or that is in between -4 and 2. And in this case, 0 is a great number to choose. And then choose some x that's greater than 2. Let's say 3. And then we're going to go and plug in these x's each into this expression and see if the result is negative or positive. Because if it's negative for -6, it will be negative for any number less than -4. Because if it ever changed, we would have to be 0 at some point, and we are only 0 in 2 places. So all of these x's have the same sign. All of these x's have the same sign, and all of these x's have the same sign. So I'm going to go and choose an x from each region, plug it in, and see if my result is negative or positive. Okay? And guys, really, I don't care about the numbers, like what the precise numbers are, because I'm multiplying. All I care about is negative or positive, because I know that if the signs are the same, then my result is going to be positive. So plugging in -6 into x minus 4, I'm sorry, x plus 4, I get -2, which is a negative. Plugging -6 into x minus 2, I get -8. Another negative. A negative times a negative is a positive. So we are positive. All x's less than -4 give a positive result in this expression. Plugging in 0, I get 4, positive number, minus 2, negative number. Positive times a negative is a negative. Plugging in 3, for x here, I get 7 times 1. So that I get a positive times a positive, and that's a positive answer. Okay? So what this is, guys, is this is a map of when this expression is positive, negative, and 0. It is 0 here and here. So having made this map, I can now answer this question. When is this expression less than 0? AKA, when is it negative? Well, for all x's from -4 to 2. Now, because this is strictly less than 0, I can't include -4 and 2 in my answer because we are 0 there, so I use parentheses. All right. Now, I know I'm over time, but this is just going to be a long lesson. Let's take a look at one more example so we see the whole procedure without any more explanation. 6x squared is greater than or equal to 2 minus x. So first step is to pretend that this is an equation. Pull everything to one side. Plus x, 6x squared plus x minus 2 is greater than or equal to 0, and factor. That's a 0, by the way, not a 6. So this is going to factor. Check my work, but I believe my factors are 3x squared and 2x squared. I'm sorry, 3x and 2x, not squared. And plus 2 and minus 1. I believe these are my factors. This is 0 when x is -2/3. This is 0 when x is 1/2. So this expression is 0 when x is 1/2 and -2/3. So I mark those two places on the number line, and this divides my number line once again into 3 regions, all of which will have the same sign when I plug these x's into the expression. So I need to choose some x that's less than -2/3. How about -1? Choose some x that is in between -2/3 and 1/2. How about 0? And then choose some x that is greater than 1/2. Let's say 1. Okay. Plugging in -1 or -1, I'm going to get -3 plus 2. That's a negative number. I'm going to get -2 minus 1. That's a negative number. Two negatives make a positive. Plugging in 0 here, I'm going to get 2 positive times -1 negative. It's going to give me a negative result. Plugging in 1 here, I'm going to get 3 times 1 is 3 plus 2 is 5, positive. Plugging in 1 here, I'm going to get 2 times 1 is 2, minus 1 is 1, positive. Positive times a positive is a positive. So this expression is positive for all x's less than less than -2/3. It's negative for all x's between -2/3 and 1/2, and it's positive for all x's greater than 1/2. I want to be greater than 0, so I want the positive intervals, of which there are 2. All x's from negative in infinity to -2/3. And then I'll union that with all x's from 1/2 to infinity. Now, because this is greater than or equal to, that or equal to means that this expression can be 0. So I can include -2/3 and 1/2, and so I have brackets. Okay, I know I am over time. We will talk more about this tomorrow, but I wanted there to be another example on the books. I'll leave you guys for later. Have a great day. Bye.